So this is about micro partitions. Then we will see about warehouse. Okay, complete how the warehouse going to work. Okay. So this is a way of creating the warehouse. Okay. Then here you can see some options we have directly. So we have projects, engagement, transformations, okay, monitoring, and then one. So here we have manage, compute. So warehouses. Okay, click on this one. So by default, we can see warehouse like this. Okay, trans we created. So these are by default we have. So everything is suspended because of we have not run any query for last 300 minutes. So that's why it's suspended. The clusters 1 to 5. So directly here from this point we can create the warehouse. Place warehouse. We can give warehouse name. So warehouse like we have two types. Standard and standard edition 2 and Snowpark optimized. So this will be used in the they are doing like AI ML work. Yeah, they will use. They're going to use Python PyPark. That's they're going to use. So this Snowpark optimized. Here we have standard generation 2. This is one new one, updated one. Okay. So software optimizations for different purpose. Okay. So in our real time, we're going to use Snowflake original industry leading standard virtual warehouse. We're going to use the this warehouse. This was standard warehouse. And warehouse comes like small. So small warehouse and again small two. This one small, medium, large. Small, medium, large. So before small we have x small and after large we have x large, 2x, 3x, 4x large. So for 1 hour it's taking 1 credit, 2 credits and 4. So like that we have 128 credits up to 4x large. So how it will going to work, I will explain. So after that, we can see advanced options here. Okay. So auto resume, auto suspend. Okay. So we given 500 minutes, like 300 seconds. Here you can see the so multi cluster warehouse. So this one. So this one multi cluster warehouse. So warehouse is warehouse, and what is a multi cluster warehouse? Suppose the warehouse using only one clusters. So it is like warehouse normal. So the warehouse if going to use more than one clusters, that we can call multi-cluster warehouse. Okay. So this is minimum clusters. In the syntax we mentioned, right? So one and the maximum cluster 5. So like that. So this is minimum cluster 1 and a maximum cluster 2. And here scaling policy standard and economic. Okay. So standard will take some price, more price, and it will be uh, lower price. Okay. So on the requirement we going to use standard economy. So economy will save the cost. Standard it will take high cost. Okay. Scaling policy. So here we going to use. Okay. So what are the up to how many clusters we can give maximum? So I'm giving 10. This is previous one minimum clusters. So one maximum cluster 10. This previous one. So now Snowflake is updated. So now it's taking the 300 clusters. You can apply the 300 clusters. Okay. Now suppose if I give 301, magic clusters cannot exceed 300. So this is new updated up to 300. But in real time, so we're going to use minimum clusters 1, magic 10. These are enough. We're not going to use the up to 300 clusters even project. Okay, you can give. Suppose I'm giving here 5 clusters. Okay, I'm giving 5. That's fine. Suppose I'm giving lower value 4. It won't take. So maximum clusters cannot be less than the minimum clusters, and the minimum clusters cannot be exist the maximum clusters. Okay. So this is a lower number. So this is higher number, or you can give both the equal. That's okay. So how it going to run? I will explain. Okay, I'm giving here 2 1. Give 10. We have 10 clusters. Okay. So suppose in Snowflake I'm running one query. Okay. One running query. It will taking the time like 60 minutes. Okay, one query. So it taking the time 60 minutes. So we are in the medium warehouse. So medium warehouse for 1 hour it taking the time 60 minutes taking the like 4 credits and like $4. $4. Suppose what I'm doing, I'm increasing the clusters up to 10 I'm making the clusters. So the same query it will take only 6 minutes, 60 by 10, 6 minutes only. But the grid going to be 4 into, here already you have 4, right? So 10 into 4, I increase the clusters 10, right? So we need to multiply 10 into 4. It is going to take $40. You're going to take $40 simply. Suppose I'm taking uh, small, it is like only $1. So for 1 hour it taking, okay, $1. That query it is going to run 60 minutes. But when I'm applying clusters 10, so then it's going to take the running time is going to take only 6 minutes, but it will take the 10 into 1 like $10. So this is going to change. Suppose if you're going to use more clusters, okay, it's going to take the more money, more cost. And if you are not using like any credits, it's going to take only one credit only for the 1 hour. If you uh, increase the clusters, it's going to take the more money. So this will about this warehouse, okay, clusters. And one more thing, here we have small, medium, large. When we going to use this small, medium, large means suppose, so when we are loading data S3 to Snowflake, uh, large files we are loading and it is taking longer time, long time. So in that scenario we're going to increase the warehouse size small to medium or medium to large, so that we can call.
Madhu,
Yeah.
yeah, sorry for the interrupt. I have one query. Okay. On which basis, okay, we can create the warehouse? Like, for example, the
One second.
Snowflake has a one warehouse, or we can create different warehouses.
One second. One second. One second. 1 minute. I will come. Avinash, you can ask now. Sorry.
Yeah.
Tell me.
So
Yeah.
we can create a multiple warehouses, right?
Yes, yes. We can create multiple warehouse.
So is there any relationship between the warehouses?
No,
We
no, no.
can connect.
I already told,
Okay.
right? There is no
Yeah.
relation between each virtual. Both every warehouse is independent. You're told, right? So this is independent.
Okay.
This is
Okay.
independent.
Okay.
Okay. Uh,
Understood. Understood.
so why we going to create, like we have different environment, like dev environment, test environment, and production environment. Okay. So
Okay. Okay.
different environment person they going to use different one warehouse, different warehouse they going to use. Okay. In the scenario,
Okay.
they will create. It will done by the admin. Just this one. Why I'm explaining? Why I'm explaining means like we need to have the knowledge. So nowadays they're
Okay.
asking interview about these things. That's why I'm explaining. So yeah, the developer
Okay. Okay.
is not our
Understood.
job. Just we need to learn this one.
Okay, okay. Then I thought, na, so if, for example, if we take any company, right, any product like us, any Santur soap, like we can create a for a warehouse for sales, and we can create a for a warehouse for production, like that only, or everything will be in the same warehouse. How
No,
how
no,
we assume so, like
no,
that?
no, no.
Yeah.
Different warehouse they're going to use in real time. Different warehouses. So dev they're going to use one warehouse and test one and one more
Okay.
prod they're going to use. So that I will
Okay.
explain.
Okay.
Still, I will explain. Okay. Here,
Okay. Okay.
the
Understood.
price will be this one. Okay. $1 it will take, but if you increase the clusters, it's going to take the $10. Okay. So that is like multi clusters. So usually go with always in your project how many clusters they are using. You need to go with the minimum. like 1 to 10 only. Don't go with 10 because of it's updated. Up to 300 is updated, only feature updated. But suppose if you increase 300, it will take for an X small, if you're taking 300, it's going to cost like 300. So that is very more expensive. So we go with 1 to 10 clusters. So in projects also they are using only 1 to 10 clusters only. Okay. So they need, if you want to increase the clusters, like they go with AML work, Python's perfect in that scenario. So why the clusters means, now I am the one user working in dev environment. There is in test environment some more team there, and in proud some more team there, another guy with working with the DBT, connecting with Snowflake and DBT. Their reporting team, they will connect with Snowflake, and they are generating the reports. So when there are multiple users are working in that scenario, so we need to increase the clusters. Remember that one. So in workload, okay, in that scenario, we're going to using the clusters, increasing the clusters. This one. So small, medium, large. So in Snowflake, we have two scales, like vertical scaling and horizontal scaling. Okay? So vertical scaling is like scale up and scale down. Scale up is like I'm going to small to medium, medium to large. That is scale up. Scale down means so large to medium, medium to small. That is scale down. It means like increase the warehouse size and decrease the warehouse size. So that we can call like vertical scaling. So when we going to do this, so when we are loading data from ST to Snowflake, suppose we are receiving large data, it's taking more time. So in that scenario, we're going to increase the warehouse size. So that one scenario. And in when we are running the query, it's taking longer time. Taking uh, like 60 minutes, 2 hours in that scenario. So we will go with the increase in the clusters, cluster power. One cluster two, it means like we are increasing the compute power. Simple like, so compute power we are increasing. So when the query runs slow in that scenario, we're going to use this one. Also, we're going to use the increase the warehouse size also. So we can do both, increase the warehouse size or increase the cluster, both we can do. And this compute cluster, when we are like multiple users are working, so in that scenario we're going to use the so multi-cluster warehouse, we need to increase the clusters. Okay, this one. So vertical scaling, scale up, scale down. Horizontal scaling, scale out, scaling. Scale out means increasing the clusters. Scaling is decreasing the cluster, removing the clusters. Scale out, adding the clusters, and scaling, removing the clusters. Okay, so remember this concept. Okay? So I will explain. So Snowflake is like multi-cluster warehouse. Okay, so here we have vertical scaling. Okay, vertical scaling. So like scale up and scale down, and horizontal scale, and scale out, and scaling, scale out and scale. Okay, this one. Okay. So this is remember they will ask in interview. They will ask in interview what is the difference between scale up and scale out. They will ask in interview what is the difference between the scale up and scale out. Then we need to say scale up means like it is a vertical scaling. We need to increase the warehouse size when we need it. In the data loading is slow. Okay, scale out is adding the clusters. So when the query is running slow in that scenario, or when there are multiple users are working in that scenario, to increase the compute power. So yeah, we will go with adding the cluster. So adding the clusters is scale out. Okay, this one. And scale is removing the cluster, and scale down is decreasing the so warehouse size. So they will ask about like this only, what is the difference between a scale up or scale out, or while when data is loading slow in the Snowflake, is to the Snowflake. So what are we going to do if it's slow, and if the query is running slow, what are you going to do? Okay, and it will come in the how you do performance tuning in the Snowflake, and how you optimize the query. So those related questions answer. So we need to tell about these clusters. About the cluster, we need to tell about vertical scaling and horizontal scaling. So when I give the question in that notes, you can see everything end to end. These are the scenarios. Data loading slowly and query running slowly, and when there are multiple users are working. So in that scenario, we go with the so performance tuning, vertical scaling and horizontal scaling. Okay. So now just to read about theory, just have the idea about this edition standard. So enterprise and business critical and VPS virtual private Snowflake. We have four editions in the Snowflake. So it's a pay as use model. It is a SaaS model. No need to install anything. Okay. Then what is cluster warehouse? We need to tell about the clusters. And here, so we discussed about database story layer, compute layer, and cloud services layer. Okay. Here the data will be stored, the query will run in this layer. So not only query, we need to explain like, so if you do any transformations, data loading and data unloading, okay, so everything run in this compute layer will done in the compute layer. And cloud services is completely security and metadata optimization management completely. If you want to correct any native tools, then we going to use the cloud services layer. So the data going to store in the micro partition in the compressor format. It is a column format. Each field we have 50 to 500 MB. It knows the, so what is the manual value, what is the minimum value, what is the row count. So the way those are going to store in the Snowflake, the Snowflake knows it will done by the Snowflake by automatically. So query pruning is, it won't it won't scan the unnecessary data. It will scan only relevant data only, that is query pruning. Cluster key, so we need to apply and the large tables only. So which column we are using repeatedly, or date column or country column, like that. So what is the limit of to apply the cluster keys? There is no limit, but in real time we go with 1 2 3. So you need to say 1 or 2 in the answer the question. For that question, if they ask what are the how many clusters you are applied on a table, you need to go with 1 or 2 clusters only. It will useful for the performance tuning. Okay, we don't have the indexes in the Snowflake. It won't support. They will ask question like that. Have you worked with indexes in Snowflake? You need to say no. Indexes won't support in the Snowflake. Instead of indexes, we have micro partition and cluster key. And here, don't confuse with clusters and cluster key. Cluster key, we define in a table. Clusters are we are increase the power of the compute power of the that Snowflake, that compute layer, wearing the power workload. And also see about, so what is vertical scaling and what is horizontal scaling. So this will be increasing small to medium, medium to large. That is vertical scaling. When we the data is loading slow, we go with this one. So horizontal scaling, scale out scaling. So when the query running slow in that scenario, and there are hundred of users are working on the reporting team or other teams, in that scenario we go with horizontal scaling. Even you can tell when the data loading slow, we can use horizontal scaling or scaling also, but first to go with vertical scaling. Okay. This is multi-cluster warehouse. Okay, so we created the account. Okay, just some, this is theoretical part. We need to know how the micro partition is going to work this warehouse, and how the query scale of scaling. Okay, some theory topic. Then see, and thing, I think OLTP OLAP. Snowflake is OLAP, and other thing like Oracle SQL Server, those are OLTP. For transaction data, we use those transaction data like bank data. So for that, we use OLTP systems. For analytic purpose, we're going to use the Snowflake. That is, Snowflake is the OLAP. The Snowflake computers like Redshift, BigQuery, those are computed to the Snowflake. It is OLAP, like online analytical processing. So if Snowflake is OLTP, OLAP, they will ask like that question. Tell about what is OLTP and what is OLAP. Okay. So inserting, deleting, we use OLTP, those transactions. OLAP, like completely analytical purpose. Okay. So our work will be like simply like we need to load data. So we need to write some procedures, or we need to create UDF, or deleting duplicate values. Okay, deleting duplicate values and connectivity in TBT. We're going to create some models, or we need to do the some test. Okay, and we need to handle the historical data. We need to implement the SD type to slowly change your dimensions. So this is our work. Okay, so this will be theoretical. Everything will be, it will useful for interview purpose. Okay, that will automatically, it will done by the only Snowflake only partitions and everything. So we need to attend, and this one we need to know about theory. Then we will go with tomorrow zero copy clone. How are we going to back up the data? So, and there will different like CTS and cloning, and how it is related to the micro partition cloning. Okay, why we don't have the cost? So everything that we tomorrow we will do practically, and it both I will explain, okay, this concept. So as of now, okay, any doubt in this session? Avinash and Praveen, clear, right?
ఈ
Yeah, no,
క్లస్టర్స్
Madhu.
అండ్ మైక్రో పార్టిషన్స్ ఎలా యూజ్ చేస్తారు?
మనం మైక్రో పార్టిషన్ ఎలా యూజ్ చేస్తాను అంటున్నారా?
అవునా.
అది మనం ఏం యూజ్ చేయం. అది ఏంటంటే మనకు బై డిఫాల్ట్ గా స్నోఫ్లేక్ లో మనం టేబుల్ క్రియేషన్ డేటా ఎంటర్ చేసినప్పుడు ఆ విధంగా స్టోర్ అవుతుంది. సో ఆ
ఓకే.
పార్టిషన్ ఫార్మాట్ లో ఆ పార్టిషన్ అలా చేసుకుంటుంది. అది చెప్తే చాలా అలా స్టోర్ అవుతుంది. ఓకే, ఆటోమేటిక్ మనం డైరెక్ట్ గా వాటిని ఏమి యూజ్ చేయం. అంటే మనము టేబుల్ క్రియేట్ చేస్తాం, డేటా లోడ్ చేస్తుంటాం, ఇన్సర్ట్ చేస్తుంటాం కదా. అయితే మనకి ఏంటంటే ఇక్కడ అది బిహైండ్ లో ఎలా వర్క్ చేస్తుందో ఆ పాయింట్ ఆఫ్ వ్యూ లో మనకు తెలియాలి. దానికోసం చెప్తున్నాను. సో ఇంటర్వ్యూ అడుగుతారు వాట్ ఆర్ ద మైక్రో పార్టిషన్స్. మనం డైరెక్ట్ గా పార్టిషన్స్ ఏం యూజ్ చేయం. సో మనం టేబుల్ క్వరీ రన్ చేస్తే బై డిఫాల్ట్ గా అవి ఆటోమేటిక్ గా రన్ అవుతుంటాయి అనమాట. సో దాని ప్రకారం
ఓకే.
కాంబినేషన్ మీద అడుగుతున్నారు.
No, no, nothing.
ఓకే, ఓకే, క్లియర్ కదా, అర్థమైంది కదా. ఒక్కసారి మీరు చూసుకోండి ఎడిషన్స్, వేరే రోజు వర్టికల్ స్కేల్, హారిజాంటల్ స్కేలింగ్. సో టుమారో జీరో కాపీలోని డేటాని క్లోన్ చేయడం మీద అప్పుడు బిహైండ్ లో మళ్ళీ పార్టిషన్స్ ఎలా జరుగుతాయి. సో ఇంటర్వ్యూ పాయింట్ ఆఫ్ వ్యూ చూసుకోండి. ఓకేనా? ఓకే,
ఓకే.
ఓకే, టుమారో. ఏంది లేట్గా వచ్చారు మీరు?